Assalamualaikum warahmatullahi wabarakatuh and good days. Members of the board and top management, as the project engineering team for the Apex Urban Hub, we have prepared this comprehensive technical briefing. Developing a high-rise commercial asset within a high-density, congested urban center presents distinct engineering challenges, namely a severe restricted footprint, intricate local authority complex, and highly demanding geotechnical variables. Today, we will outline our strategic workflow spanning stage 1 to 7, demonstrating how our team will utilize precision engineering, modern technologies, and robust risk mitigation framework to transition safely from design to physical execution. We begin with stage 1 to establish complete controls over our urban footprint. A licensed surveyor will verify lot boundaries against our structural drawings to eliminate daily encroachment. Concurrently, we perform a topographical survey to map surface levels and run ground penetrating radar scan to locate buried water, gas, and power lines, entirely removing the risk of dangerous asset strikes during early works. Stage 2 handles physical and modification. We execute through clearance and grubbing to remove surface debris and deeply embedded road, preventing future soil erode under our foundation. We then optimize site grading using a cut fill strategy, moving soil from high areas to lower pocket, balancing the earthworks on site drastically cut heavy struck logistic in this congested city. Stage 3 bridge design and physical relating. We anchor our master baseline using two verified coordinate data points. From there, building center lines and primary column grids are marked using electronic total station and verified via the geometric 345 rule. Crucially, we drive off setbacks to 3 meters outside the foundation path to safely preserve our alignment marks once mass excavation begins. In stage 4, we mitigate tricky subsurface ground conditions by drilling deep exploratory boreholes across the property footprints. This allows us to scientifically classify the soil strata and pinpoint the exact water table level. This raw data gives our engineers the definitive ground-bearing capacity needed to optimize our pipe depths and prevent structural settlement. Stage 5 subject our structural foundation design to real-world stress testing before mass piling begins. We execute deep field pilot tests to verify capacity against compression and lateral shift. This is done using the cantilage method, which stacks massive concrete deck weight over a tile patch to measure physical performance under extreme load, alongside patient pile reaction system. Stage 6 secures our legal compliance through the Municipal One-Stop Center, or XC. To avoid overstoppage, we acquire layout approvals and technical clearance from essential departments, including JPP for sewerage links, BOMBA for fire safety, and both the DOE and DOSH to tightly control urban noise, machinery emission, and site safety. Finally, stage 7 established on our site operational command center once the temporary work permit is issued. Because our city center outlook features an extremely cramped footprint, we will deploy high efficiency vertically stacked modular container office. This double deck configuration preserves maximum ground space for machinery staging, safe material laydown, and piling zone. For our structural phase, we are comparing traditional timber formwork against the industrialized building system IBS. Given our cramped urban site, the industrialized approach is the superior choice. Traditional methods require massive on-site storage for raw materials, which would paralyze our limited footprint. In contrast, industrialized precast component utilize just-in-time delivery, lifting directly from the truck to the structure. From an environment standpoint, traditional methods create significant waste and a messy workspace. The industrialized system provides a clean, factory standard assembly process that minimizes site congestion. Furthermore, while traditional methods are labor-intensive and quality-dependent on manual skill, the industrial building system IBS offers consistent factory control, precision. This modern method allows us to bypass the labor shortage while delivering an accelerated timeline and superior quality for the Apex Urban Hub. For our substructure and material handling, selecting the right machinery is entirely dictating our site survival. First, we reject standard hammerhead cranes because their fixed horizontal jibs swing freely over public roads and neighboring structure, creating a severe legal and safety hazard. Instead, we are deploying a luffing jib tower crane. Because it can raise and lower its arms vertically, it operates with absolute precision entirely within our own property boundaries, completely eliminating airspace encroachment. Second, massive track excavated like the turning radius needed here and risk colliding with perimeter safety holding. We are utilizing mini excavators and compact skid steers. Their highly compact tail swing allows them to safely and fluidly dig foundation hole inside their tight corners. Finally, to handle wet concrete without blocking municipal roads, we will position stationary compact concrete boom pumps within designated on-site waste wash bays. Ready-made trucks can enter the site limit, discharge immediately into the pump hopper, wash their tires, and exit without creating city traffic jams.
Assalamualaikum and a very good day. My name is Amir Muhammad bin Muhammad Shukri and number matric 2T303379. and I represent the project engineering team for the task part 2, which are new technologies that we can propose in the project, the local activities approval, and the uniform building bylaws UBBL and license control. So, if the issue of limited space and difficult soil conditions, technology plays an important role along with the legal requirements in the management of a construction operations and a public license. So, let us start with our innovation engine. So, to execute this project faster and safer, we are integrating a building information modeling, or known as BIM, and also the construction robotics. So, firstly, BIM acts as our digital brain. On a site where a space is practically non-existent, BIM's 4D scheduling prevents structure clashes and allows for a just-in-time material deliveries, completely eliminating the need for a vast storage space. Safely, it allows our team to run a virtual walkthroughs to proactively map for hazard before workers even arrive. So, moving to the next part, which is secondly is construction robotics. We will deploy the automated layout robots to print floor plans directly onto the concrete slabs, cutting the survey time from the day to hours. For our deep foundation works in these tricky soils, a remote control excavators human operators is very safely isolated from a trench cave-in zones. BIM fit the spatial coordinates which the robotic execute them flawlessly. So, moving to the legal compliance, we will secure a planning permission through the One-Stop Center (OSC). This is a streamlined gateway. Our principle submitting a person submits the digital plans and the OSC concurrently distributes them to the internal council departments and external technical agency. Because our BIM models ensures a full regulatory and compliance during the design phase, we anticipate a rapid clearance from the OSC commit to officially commence work. So, and finally, regarding a public license, operating in a dense city requires a strict adherence to the Uniform Building Bylaws, which is UBBL. For dust control, we are implementing automated truck wheel washing facilities at all exits and installing a heavy-duty perimeter netting to trap airborne particles. To mitigate the noise, we commit to strict adherence to permitted working hours and will deploy the acoustic barrier around our heavy machinery. Crucially, we will prevent several traffic jams, which is by meticulously scheduling a heavy vehicle logistics during off-peak hours. We have optimized our site movement to maintain at the surrounding intersections at an acceptable level of service D and preventing them from failing to an F. I think that's all for me. Thank you.
Hi, my name is Muhammad Haikal Harid bin Muhammad Zaiham with metric number 23303845. So, if weak soil conditions are encountered on site, our first action is to conduct a detailed soil investigation. This includes borehole drilling and standard penetration tests, or SPT, to determine soil strength and bearing capacity. Next, we will perform load testing to verify foundation performance. One method is the cartilage test, where heavy weight are placed on the pile to measure settlements. Another method is the use of friction piles, which transfer load through skin friction along the pile surface rather than relying on weak soil at the base. Based on this result, we will redesign the foundation system if necessary, such as increasing pile depth or switching to board piles. This ensures the structure remains safe, stable, and compliant with engineering standards. Next, to address poor material quality, we implement a strict QA/QC system, which stands for Quality Assurance and Quality Control. First, under quality assurance, we establish procedures such as supplier approval, material specifications, and inspection plans before the construction begins. Then, under quality control, incoming materials are tested on site or in laboratories. For example, concrete is tested using slump tests and cube strength tests, which steel reinforcement undergoes tester strength testing. Materials that fails to meet standard will be rejected immediately and replaced. Additionally, all test results are documented and verified before approval. This system ensures that only high-quality material are used, preventing structural defects and ensuring long-term durability. Lastly, if the project falls beyond schedule, we will implement a master construction program to regain control. First, we analyze the delay using tools such as critical path method, which help identify activities that directly impact the project timeline. Next, we revise the schedule by relocating resources, increasing manpower, or introducing overtime work where necessary. We also improve coordination through regular site meeting and real-time progress tracking using digital tools. If required, we apply fast tracking method by overlapping activities that are originally sequential. This structured approach ensures delays are minimized and the project is completed within the required time frame.